नमस्कार. अंतरिक्ष अप एंड अवेत सगळ्यांक परतून येवकार. सध्या सगळेकडे ब्रेकिंग न्यूज आसा आणि सगळेच कडे फक्त एकूच चर्चा चालू आसा लोकांची आणि ती म्हणजे पावस चालू आसा जोरान. आमचो मॉन्सून सीझन पिकार आसा आणि आज आमचो स्पेशल एपिसोड आसा अर्थ वॉच एपिसोड, जातून आमी आमची पृथ्वी, आमची प्लॅनेट सारकी वळखुवपाचे प्रयत्न करतात. आणि ते करपाक मॉन्सून हे टॉपिकाचेर उलोवपाक म्हाका दिसता सगळ्यान बेस्ट पर्सन आमच्या पुराय गोंयांत आसूं शकता, सगळ्यान बेस्ट पर्सन आज आमच्या स्टुडियोत आमी आमंत्रीत केल्यात. येवकार करुया डॉक्टर रमेश कुमार. वेलकम डॉक्टर टू द प्रोग्राम.
थँक्यू.
डॉक्टर रमेश कुमार हे NIO म्हणजे डॉनोपावल हांगा आशिल्ले नॅशनल इन्स्टिट्यूट ऑफ ओशनोग्राफी हांगा चीफ सायंटिस्ट आसात आणि अर्थ सायन्सीस डिपार्टमेंट तातूंत ते NIOन असतात. आणि सगळ्यान मेन डॉक्टरांची वळख म्हणल्यार इंडियन मॉन्सून्स इन गोवा हे टॉपिकांचेर, पावस ह्या टॉपिकांचेर तांणी बरेच रिसर्च स्टडी केल्यात आणि एकदम एक्सपर्ट आसा ते हे सब्जेक्टाचेर. सो डायरेक्टली आमी चालू करुया. डॉक्टर वेलकम टू द प्रोग्राम.
Thank you.
आय विल आस्क यू द फर्स्ट क्वेश्चन. जे आमचे सगळ्यात मनान एक कुतूहल असता, वन इन्क्विजिटिव्हनेस इज देर, की वॉट एक्झॅक्टली इज दिस मॉन्सून. पावस पडटा सगळ्यांक खबर आसा, जॉग्राफीन आमी शिकतात, दॅट इज ओके, बट वॉट एक्झॅक्टली सायंटिफिकली इज द इंडियन मॉन्सून, वॉट इज द फेनोमेना.
आम तेका सांगता मॉन्सून म्हणल्यार इंडियाचे ते इंडियन सबकॉन्टिनेंटाचे सिंगल मोस्ट इम्पॉर्टंट मिटिओरॉलॉजिकल फिनॉमिना आसा. ते कित्याक 75% आमचे एन्युअल रेनफॉल हे 4 महिने पडता. जून, जुलय, ऑगस्ट, सप्टेंबरा पावता. ते पडता म्हणून न्ही ते एग्रिकल्चराक लागून इम्पॉर्टंट आसा, हायड्रो इलेक्ट्रिक पावराक लागून इम्पॉर्टंट आसा, आमचे ड्रिंकिंग वॉटर उदकाक लागून, पिवपा उदकाक लागून इम्पॉर्टंट आसा. लायफ ताका इम्पॉर्टंट आसा. आनी कित्याक ते डिफरंट म्हणल्यार आमी सांगता तुका, तर आतां ताजे फुडें आमी एक सांगता, lot of people get confused between weather and climate. Weather म्हणल्यार आमचे एक instantaneous information आसा of a small region or a small point. Climate म्हणल्यार larger area for a prolonged period of time. 20-30 वर्षाक लागून आमी climate म्हणटा.
Climate and weather is different.
People use it loosely or maybe unknowingly. So there should be a subtle difference between weather and climate which people should understand. Okay. And now कित्याक आमी monsoon शिकता. Other for example this year. Look, everybody is scared that it will be going to be a drought here.
That is also one question, doctor, which I wanted to ask. Ki there is a scare, there was a scare, पण आता सगळ्याकडे पहिल्या दिवशी तसे I don't feel की we are having less monsoon, deficit monsoon. What is this deficit monsoon?
Okay, I'll explain that. If you look at here, for example, in 2013, which was actually a normal year, only a few meteorological subdivisions had actually less amount of rainfall. Last year, for example,
pink म्हणजे less rainfall.
And deficit monsoon आसा. Okay, that these colors are actually deficit monsoon. If you look at last year, for example, in fact last year was supposed to be one of the El Nino of the century, or maybe much more stronger than this year, but fortunately for us it didn't happen, and only few meteorological subdivisions were actually less or deficit monsoon of rainfall. Now let me come to the first question. Why Indian monsoon or Asian monsoon? How is it different?
What is the monsoon?
For the monsoon, the oceans, for example, play a very important role. And I come from a National Institute of Oceanography. Unlike Pacific Ocean or Atlantic Ocean, which are connected from pole to pole, only in Indian Ocean, if you look at, we have lot of landmass in the northern hemisphere and lot of ocean in the southern hemisphere. So during the month May to October, we have a high pressure system somewhere around 30 degrees south. We call it Massacrine High. Around the same period, the places like Saudi Arabia, Afghanistan, Pakistan, all these area get heated up, and we have a low pressure system. So we have a high pressure system over around 30 degrees south and a low pressure system around these areas. So winds flow from high pressure to low pressure, and once they cross the equator, because of the Coriolis effect, they turn as southwesterlies or southwest monsoon. This is in a very simple fashion, basically due to the land and thermal contrast. And not only that, if you look at in the month of January, the whole of sea surface temperature is actually in the southern hemisphere. If you look at the month of July, everything is the warm pole. If you look at the previous figure, you can see the warm pole, which is more than 28 degrees Celsius. It is south of the southern hemisphere. And if you look at in the month of July, it actually moves to the northern hemisphere. The same is the case actually of the clouds and whatever. You can see in the month of winter, it is around 10 degrees south. But if you look at the month of July, it goes almost 25 to 30 degrees north. So is the case of the winds. So Now, why each monsoon is unique?
So basically what you said, doctor, is I think,
Yeah.
if I've understood,
Yeah.
monsoon means reversal.
Yeah.
A reversal of weather, something like that.
Now, I'll put it in a simple fashion. It's actually a coupling of ocean, atmosphere and land phenomena.
Okay.
See, basically we think only of land and ocean.
Okay.
But atmosphere also plays a very important role.
Okay.
So it's actually land, ocean, atmosphere coupling monsoon.
It is a system.
Exactly. It's a entire system plays an important
Okay,
role.
okay.
And each monsoon is unique. Each monsoon is unique in three important aspects. One is actually the monsoon onset, which takes place over Kerala. And active break cycles. For example, last week, if you remember, there are several days where the monsoon rainfall over Panji or Mormugao, almost 10 to 12 centimeters of rainfall fell in one day.
Very heavy rainfall.
And even places like say Mumbai, for example, the whole of the life was at standstill.
Flooding was there.
Flooding was there. Aircrafts couldn't land. The trains were actually standstill. So, and if you remember a couple of years back, way back in 2009 or 7, we had almost 94 centimeters of rainfall. This year it was only 30 centimeters.
Yes.
So these things are actually, we call it intense or we call it active monsoon condition.
Okay.
Another important aspect is the quantum of monsoon rainfall, which falls over various meteorological subdivisions. Now, coming to this, as you correctly asked, how does the monsoon come and how does it progress? The monsoon starts coming from the southernmost part of India. We call it state of Kerala.
It starts from Kerala.
And slowly progresses and covers the entire Indian subcontinent by about 45 days or by 15th of July.
Okay.
But it's not the same. For example, some years, way back in 1918, it came almost by 11th of May. And it was as late as 18th of June in 1972.
Okay.
So you can see there is so much.
Fluctuates.
It fluctuates year to year. And there's, for example, this year, it came only on 5th of June. So there is so much variability from year to year.
Exactly. Now this year's break.
Yeah.
So how do they कशे calculate करतात की this year there is going to be a deficit monsoon,
Okay.
and less monsoon, more monsoon. कशे ते on what aspects do they calculate a deficit monsoon?
Okay. Now let me, as you correctly said, let me come to this year's monsoon, for example. You can see it started coming only from this one and it reached. One interesting fact, if you remember, couple of years back, way back in 2013, it covered the entire Indian subcontinent in 16 days. Okay, as I said, it takes about 45 days, whereas it took almost 76 days for it to cover in the year 2002.
Okay.
So
it goes slower.
Yeah, it goes slower, or it's not actually, it goes in a linear progression.
Okay.
Some years, as I said, it takes 16 days. In 2013, we had actually Uttarakhand floods, if you remember.
Yes.
Whereas in 2002 was one of the worst drought or deficit years.
Okay.
So I will come to that. Now coming to this year, for example, there are several systems which form. And this year we had only one system. There is actually a cyclone called Ashoba, which actually was there, and that also actually helped actually in progress. Now let me come to this. For example, India Meteorological Department has very clearly said that it is going to have only 88% of the long period average rainfall. Okay.
What does this mean, doctor?
Yeah. Basically, it means actually it's going to be a drought condition.
Okay. In India, we are going to have less rains.
Less rains according to IMD.
Okay.
And the monthly rainfall of the country also is likely to differ. Now, as you correctly said, what parameters we have used for predicting it?
How do we predict that this year will be deficit?
Yeah, basically they have used several parameters, like say this temperature gradient between Northeast Pacific and Northwest Atlantic, South Equatorial Indian Ocean sea surface temperature, East Asian mean sea level. There are a variety of parameters, like the 6 predictors they have used to predict this one.
Okay.
Plus, in addition, this year there is actually a fear that El Nino is going to become more and more stronger. So that El Nino can have actually a profound influence on the Indian summer monsoon. People have been knowing for years.
Monsoon rains are now covering most of India's traditional grain belt in the Ganges River basin, nearly 2 weeks later than usual. The rains bring much-needed relief to farmers and politicians who fear the effects of a late monsoon on crops like corn, sugar, and rice. In fact, New Delhi's intense focus on the monsoon's course this year shows just how central the seasonal rains remain to life in India. Thanks to modern irrigation technologies, shifts in the timing of the monsoon no longer mean famine, but they do affect the Indian government's bottom line. The South Asian monsoon is a system of winds that reverse direction at roughly the same time every year. As they move up and down the Indian subcontinent, these winds carry fresh water to hundreds of millions of farmers. Consequently, the usually highly predictable monsoon rains are the lifeblood of agriculture throughout the Indian subcontinent. The monsoon has 2 phases. The first carries moisture from the Arabian Sea up through the Indian subcontinent. It begins in June and covers most of India with rain until September. In late September, these winds reach the Himalayas and make an abrupt about-face. From late October to December, the monsoon glides back down over the subcontinent on its way to the Indian Ocean. Agriculture accounts for 18% of India's GDP and employs around half of its total workforce. The monsoon rains are the main source of water for 55% of the country's arable land. This means the rains are crucial not only for India's farmers, but its economy as a whole. Now, that's a good thing when the monsoon arrives on time and brings the right amount of rain. But when it's late or weak, it leads to drought. When it's too strong, it can trigger floods. The two-phase pattern of the winds defines Indian agriculture, so when the pattern shifts even slightly, it can have real implications for food production. In the past, seasonal fluctuation was a matter of life or death for Indian farmers. A bad year meant widespread famine. Today, the situation is somewhat different. Most parts of India now have irrigation systems that farmers can turn to in an emergency. So even when rains are late or weak, as they have been this year, farmers have ways to supplement them. Anxiety over delayed rains is nothing new. This anxiety is like the rains themselves, a staple of Indian life. The monsoon isn't just the key climatic or agricultural event in the Indian subcontinent, it's the key economic event. Its effects reach far beyond agricultural output, shaping political dynamics on both the regional and national levels.
Now, Doctor, the important question,
Yeah.
which आमच्या सगळ्या दर्शकांच्या मनान आसतले, आणि again and again you have mentioned.
Yeah.
Can you explain to us in simple terms El Nino and La Nina, these
Okay.
two weather conditions,
Okay.
which internationally are very
No.
discussed about.
Yeah.
But I mean, Goyan,
Yeah.
we don't
Okay.
know much about this El
Okay.
Nino and La Nina.
Okay, I will explain in a. This is actually a typical normal condition asa. And mind you, a Pacific Ocean asa. Okay.
Okay.
Pacific Oceanat आमच्या Eastern Pacific
Okay.
temperature वाढता. थंगा वाढता जाल्यार the whole of that Peru region,
Okay.
the fisheries over that
South
region,
America.
South America.
Okay.
It's actually in the Pacific Ocean, South America, in the Peru region. If the sea surface temperature increases,
Yes, okay.
thanga the fisheries yen jatale,
Okay.
and that it will actually have some convection over there, and that can have actually disrupt Walker circulation, atmospheric circulation asa.
Okay.
Whereas in a typical La Nina or normal condition, thanga SST, sea surface temperatures are cooler.
Okay.
You get lots and lots of fisheries.
Okay.
Normal or La Nina
Means
conditions,
the fish catch gets affected.
fish catch gets affected, and not only that, it affects the atmospheric as well as the rainfall conditions over there.
Okay.
So in a typical normal or La Nina conditions, the whole what we have is actually only typical Walker circulation.
Okay.
Whereas during an El Nino condition, the Walker circulation gets let's say
Okay.
into two different parts,
Got it.
and the central gets actually warmed,
Yes.
and it affects actually our monsoon.
So, if I understand, El Nino
Yeah.
is the heating of the oceans.
Exactly.
And La Nina is the opposite, cooling
Opposite.
of the oceans.
Exactly.
And these have adverse effects.
In terms of actually the atmospheric circulation
Yeah.
and Walker
And
circulation.
even breeding of fish and fish.
Exactly. It affects the fisheries, especially in the Peru coast.
Exactly.
In 1998, storms raged over the western portion of North America. Torrential downpours collapsed hillsides, destroyed property, and left many homeless. These destructive storms were a part of a force of nature known as El Niño. Its existence has been known since the 19th century. The seasonal arrival of warm waters around Christmas led South American fishermen to dub the phenomenon El Niño, Spanish for the Christ child. What can escalate into a powerful and deadly force of nature starts deep in the tropical Pacific. Scientists theorize that a cyclical weather change allows the westerly trade winds to dwindle. This causes a giant pool of warm water to form along the equator that can span half the size of the United States and pack more energy than 1 million atomic bombs. As this mass of warm water travels eastward, a ripple effect on weather of global proportions unfolds over a matter of months, causing severe storms